All right, in this video, we're going to look at Earth's early history as it pertains to life on Earth. So one of the questions that we hear a lot of times is, how did life begin? And obviously, nobody was there, so we don't know for sure. But we've got some hypotheses based on evidence about what we believe the environment was like, and it was very different than what it is today. So ancient Earth, like I said, was very different from Earth today. One of the major differences was the atmosphere, along with the fact that the Earth was very geologically active, lots of volcanic activity. It was much hotter, things like that. But the atmosphere had little or no oxygen. It was what we call a reducing atmosphere. That's a big deal. What the atmosphere did have a lot of was carbon dioxide, water vapor, and nitrogen, with some carbon dioxide, hydrogen sulfide, and hydrogen cyanide gases as well. And this environment allowed for organic molecules to spontaneously form and life to begin. In 1953, two scientists, Miller and Urey, designed an experiment to test the hypothesis that organic compounds could have formed spontaneously on early Earth. More recently, we've changed the experiment to fit with the current data, and it showed not only did their experiment show that we could have these organic compounds, but we found organic compounds on places like meteorites and in comets. So here's kind of what it looked like. So in this area here, water vapor was heated because the Earth was very hot. There wasn't a lot of water vapor in the atmosphere. Again, methane, ammonia, hydrogen, things like that in the atmosphere. A lot of electrical activity, a lot of storms, so a lot of lightning, which could have provided an electrical spark, which then could, as the water cooled, form droplets. And they checked every once in a while, and they found that it did contain amino acids and other organic compounds after several weeks. So it supported the idea that organic molecules could form spontaneously. Now, at one time, there was this idea that living things today could form from non-living things, and there was some evidence that seemed to support that idea. But Louis Pasteur designed an experiment that disproved that. And one of the things that prevents that from happening today is the fact that the atmosphere is very different today. It has oxygen, so it's an oxidizing environment, which prevents those things from happening. So another thing that helps support this idea that life could have began spontaneously on Earth is that fatty acids, the building blocks of membrane lipids, can form spontaneously under similar conditions to the other organic compounds, forming protocells, where a cell could have trapped in some of these organic molecules and become the first protocells, which could then become true living cells. Now, one of the things that is kind of difficult to deal with was DNA. So we know that RNA can work as a information storage molecule. It does in some viruses. And so RNA is a little bit simpler molecule than DNA, and there's fewer steps to go from RNA to making proteins than going from DNA to RNA to protein. So RNA could have been the first genetic material. RNA can self-replicate, it can synthesize proteins, and it can function in information storage. So it would do all of those things that we needed to do in terms of directing the formation of molecules. So the first evidence of living things on Earth shows up in the fossil record about 3.5 billion years ago. And then about 2.2 billion years ago, photosynthetic bacteria show up, and the atmosphere starts to change. It becomes an oxidizing environment instead of a reducing environment. So those are prokaryotes, don't have a nucleus, very simple. Eukaryotes show up about 2.1 billion years ago. And the current theory that explains how eukaryotes came about is what we call the endosymbiotic theory, where organelles, especially mitochondria and chloroplasts, could have formed by cells incorporating other smaller cells. And the fact that mitochondria and chloroplasts have their own DNA that has a different genetic code than the DNA in the nucleus of the cell is one of the things that supports this idea. So it goes kind of like this. You have ancient aerobic bacteria, you have an ancient anaerobic prokaryote. It traps the DNA in a protonucleus. It traps a cell like a sulfur bacteria, purple bacteria that could become the mitochondria, or some kind of photosynthetic organism that became the chloroplasts. And eventually those gave rise to all of the eukaryotic cells that we see today. So life is pretty complex, and cells are pretty complex. So again, going back to this idea of genetic material, RNA can act as its own enzyme. It can form the ribosomes with the proteins. It can do all of the things that we need genetic material to do. Other structures like flagella have protein subunits that have other purposes in other parts of the cell. So again, it wasn't like it was completely building a whole new structure to come up with these structures.